to Zigmatic Consult. Today we shall be discussing energy-based technological appliances 2. By the end of this lesson, you should be able to define electric motor, list important parts of an electric motor, state the examples of different appliances that operate on the principle of conversion of electrical energy to mechanical energy. You should be also able to explain how the refrigerator works. You should also be able to explain how the generator works. So let's dive into this class properly. Now, a motor is a device that can convert electrical energy into mechanical energy. So whenever we talk about appliances that can convert electrical energy into mechanical energy, there is no other device that can do that in all of these appliances that I'm going to list for you that does not have motor in it. So when we talk about mechanical energy, alright, most of you will think we're talking about energy from mechanic, or maybe energy that is used to do mechanical work. Like, I don't know how you understand it. So when we say mechanical energy, obviously what we're talking about here is energy possessed by a body that's either in motion or that's possessed by a body using of the position of that body. Do you understand what I'm saying? The energy a body possesses by virtue of the motion of the body or by reason of the position of the body. That's what we mean by mechanical energy. So, appliances that you see them move when they're in operation, it means that they possess mechanical energy. For example, the fan. When you turn on electric fan, the blade rotates. That's mechanical energy, you understand? So, I hope you understand what we've said now about mechanical energy. So, once we are talking about appliances that convert electrical energy to mechanical energy, just begin to think about those appliances that when you turn on the mains, that they will start moving, right? Such an appliance has motor in it. It is motor that is responsible for such movements that they make. So it's important to really understand what motor is, the working principle of motor, and different parts of a motor, right? Okay, so like I said before, that a motor is a device that can convert electrical energy into mechanical energy. That is to say, electrical energy is the input for motor, while mechanical energy is the output. You see that? Now, we have two types of motor anyway. We have DC motor, we have AC motor. DC here means direct current motor. We have alternating current motor. Understand? So that's basically the two types of motor that we have. Alright? Now let's look at motor and different parts of motor. We're going to talk about different parts of motor. Now, for every motor that you see in operation, be it DC motor and AC motor, they have the same parts we're going to look at. Number one, every motor has what we call the armature, has a commutator, has a stator. We always have a shaft. I'm going to tell you what each of these, what they do. Just, not so deep because of where we are in our academic level, right? It must have a bearing, it must have a frame, Because if everything is if not that we are doing this for class, the motor is going to be it's going to be enclosed in this frame, right? Now, what exactly are we talking about here? Okay, so see the bearing, see the shaft, the whole of this rotates. Once you have electricity supply to the brushes, you have the carbon brush, alright, you have the brush assembly. Here you have the carbon brush. The starter here is actually a magnet. Yes, it's important you know that. That's exactly what I want to use this motion picture to show you. The starter here is a magnet, a very strong magnet. Very strong magnet. So this here is like this. It's like this. Okay. Now you see the armature here has a soft iron core you are seeing here, iron core, and the different windings of wire, in the iron core. Now see what happens here. We have the commutator here. Right, this commutator here, of course, this particular motor you are seeing here is a DC motor because this commutator here is a split ring. Call it commutator. What you are seeing here is a split ring. Alright, what it does is just to ensure that the direction of the current, reverses once it gets to when it goes back and all of that. Okay, so this is a DC motor because of the commutator here. It's a split ring commutator. That's actually the difference between DC motor and AC motor is in the commutator. If it's an AC motor, here is going to be a slip ring. You're not going to have these slots in the commutator. These ones you have slots in them, right? It's called a DC commutator. So this is a DC motor, alright? Now, see what happens. See what happens for this motor, how the motor functions. You know that, like I said before, that when electric current passes through a conductor, right, it produces magnetic effect, heating effect, and also chemical effect. But in this case now, it's magnetic effect we're going to talk about here for a motor. Now, if current passes through, right, the armature through the brushes, there's going to be a magnetization. This armature will behave like a magnet. We call it electromagnet because this is a soft iron core. It has the ability to easily magnetize and easily demagnetize. Now, as it is magnetized, right? So, this already I told you is a magnet. This is exactly what you are seeing here. The stator you are seeing is a magnet. This is South Pole and North Pole. Now, this is magnetized because electricity is passing through it. That's magnetic effect of current when it passes through a conductor. This you see here, they are conductors. You see that? Now, as it is magnetized, we have the North Pole, we have the South Pole here permanently, like you see like this. Now, you already know that once this armature is magnetized, that is going to experience a force because of what we call repulsion and attraction. When like poles, when they're brought together, there's usually a repulsion. When unlike poles are brought together, there's usually an attraction. Now, this force that acts on this armature, right, produces a turning effect. Otherwise, we call moment, or you can say torque. Produces a turning effect of the armature. So, when this armature turns, right, remember that the stator is magnetized already, it's a magnet. So, as it's magnetized, so this force experience continues to rotate or turn the armature, right? As the armature is turning, this shaft you see here turns in the process. So if you have any of your devices, like you have a blade attached to this shaft, for example, fan blade, you will see that the blade of the fan will begin to turn so long as we have it connected to electricity. So but once you turn off electricity, what will happen is that the armature here gets demagnetized. So when we have this number of wires here, is to increase the rotation of this coil. To increase the rotation, because the more number of turns you have of that wire, right, the faster the shaft rotates. That is the simplest way I can explain electric motor to you and how it operates. Actually, the electric motor operates on the principle of electromagnetism. That simple thing I have explained is a concept of electromagnetism, that when we have a conductor that is carrying current, right, in a magnetic field, that conductor experiences a force, and that force causes a turning effect on that conductor. So on that principle, the electric motor operates. We call it the principle of electromagnetism. Okay, now all of these appliances, the electric fan, moves because it has motor in it. If it is standing fan, you have the back of it is the motor. That's where you have the motor. Although this fan you're seeing here, of course, we can alter the speed of this fan, of course because this fan is made up of a rheostat that enables the resistance of different ohms to flow, right? Yes, different values of resistance. So when you turn it to speed 1, for example, it means that the rheostat there has no resistance. So when the resistance there is low, what happens is that more current will flow. Alright? So that's how you alter the speed of the electric fan you have. Now we have the blender. The blender, converts electrical energy into mechanical energy. Because for you to actually blend the pineapple, blend the strawberry, all you need to do is just put your strawberry and switch the mens on, right? Switch it on. That turning of the blade is caused by the motor that is in that blender. Most of the times you say that blender has stopped working. Is that motor that stopped working? Alright? Now we have the knife. We have electric knife. Yes. We have electric knife. Can you see the way the electric knife is moving? Yes. That's because it has got motor inside. We have a washing machine. Just put your clothes inside. Washing machine turns and turns. The vacuum cleaner, the pepper grinder you have here, they all operate because it has motor in it. Now, there are also another device that you never will believe that converts or operates because a part of it is able to convert electrical energy into mechanical energy, and that is the refrigerator. So the refrigerator, like we know, right, is made up of different parts that they all work together to have the cooling that we have for either our wine or anything that we put in the refrigerator. The refrigerator operates, by actually absorbing heat from substances that you keep into the refrigerator. By so doing, it can keep the fridge cold, it can keep whatever you put the water cold. Alright? Now, it does this function by using electrical power, right? Electrical energy to power the motor that we have in the compressor. Now, the refrigerator has these components. The refrigerator has a compressor. The back of your refrigerator or freezer, there's a black substance that looks like a small pot you have. That's called a compressor. Inside that compressor, There's motor inside. That's how the refrigerator is able to perform its function. We're coming there, but just let me exhaust different parts of the refrigerator. Now we have the compressor, we have the evaporator, we have the capillary tubes, we have the thermostat of the refrigerator, we have the condenser coils, then we have the evaporator coils. There is called the evaporator. Then we also have the expansion valve, is a part of the refrigerator. Now, having known this, we call this the control relay. How does the refrigerator work? How does it function? How does the refrigerator work? How does it function? Now, you see, the refrigerator, like I said, can keep whatever we put inside of it cool by absorbing heat from the body, right? Now, this whole experience starts, in the refrigerator we have refrigeration tank. In the refrigeration tank, right, that's where you have the refrigerants, right? These refrigerants, they have the ability to change into vapor and change back from vapor to liquid state. They have that ability. Not all liquids can do that easily. And they change easily into vapor and change easily back into liquid. So we call the refrigerants, right? We call the liquid we have in the refrigerator, we call them refrigerants, right? Now, we have an example of these refrigerants. We can make use of Freon 12. Freon 12 is used as a refrigerant. Alcohol can be used as a refrigerant. Cyclopentane can also be used as a refrigerant. In your exams, you will encounter this thing I'm saying. One of this is used as a refrigerant. You see Freon. Freon is used as a refrigerant. Freon has a chemical name we call dichloro-difluoromethane. That's the chemical name, right, of Freon. Dichloro-difluoromethane. That's Freon 12. Freon 12 is preferred because of its ability to easily, change to vapor and also compress back to liquid. Now, see how the refrigerator operates. If we have everything set, the refrigerants that are there in the refrigeration tank, right? Now we have the compressor, everything is working, the expansion valve, everything is working, right? The evaporator, we have everything in place. Now, you just turn on your refrigerator. See what happens. The moment you turn on the refrigerator, the cooling starts from the refrigeration tank. In this tank is where we have the refrigerants. Now, these refrigerants are pumped, right, to the expansion valve. See what I'm telling you? They are pumped to the expansion valves. And this pumping action is done by the compressor. So what the compressor does is to pump it at a high pressure, right? Yes, to pump it. Now, the moment it enters the expansion valve, in the expansion valve, the refrigerants will expand. When the liquid expands, it simply means that the volume increases. When the volume increases, what happens is that the pressure is reduced in the expansion valve because pressure is inversely proportional to volume. That's another topic for another day. Okay. Now, when that happens, in the expansion valve that we have the Freon now is expanded. Remember I said it's pumped at a high pressure, right? It's pressured. That's the compression. It's pressured into the expansion valve. Once it's in the expansion valve, the pressure reduces in the expansion valve because the expansion valve increases the volume of the freon, so to say. Now, from that valve, right, now that the volume is increased, the pressure is reduced. Remember, in that valve, these compressed refrigerants, right, they are getting heated in the process. Now, they pass in that form straight, they pass into the evaporator. In the evaporator, they change from liquid state to gaseous state. Now, in this evaporator, remember that in some refrigerators, the evaporator is found in a compartment where you can have it cool, because as this freon evaporates, inside of the refrigerator we have, by convection, right, cool air enters the refrigerator by convection. So whatever you have inside the refrigerator, right, gets cooled by the cool air that enters the refrigerator. That's why when you mistakenly open your freezer, you have very cool breeze coming out from the freezer. It's because of the evaporation of the freon. That's what you experience. That's the convection current that you experience. Okay, so when that happens, remember I said that in the evaporator, the freon is turned into gaseous state. It evaporates. Now, from the evaporator, now at this stage, right? Remember I said the pressure is reduced. Now at this stage, the compressor, which is the pump, pumps this vapor into the condenser. Now, in the condenser, this gaseous form of the freon is condensed. It changes back into liquid form of it. Now, if it changes back, as it changes back into the liquid form of it, right, it will flow as a liquid. At this point, the volume is reduced, so it's doing that also at a high pressure. Now it's pumped back into the compressor, right? On the compressor, the whole process begins to, repeat itself. That way, as the convection current begins to flow, the cool air that's happening from the evaporator compartment begins to flow into the refrigerator. Whatever you have in the refrigerator continues to get cool and get cool and get cool and get cool. Now, the heat produced in this process, that's what the fins you have outside, the cooling fins. Okay, they are conducted to the external environment. That's why sometimes when you go to the back of a refrigerator, you touch it, you see that it is hot in the process. Now, the pumping of the freon around the freezer and the freeze that is done by the compressor is done because the compressor has a motor in it. It is this motor that turns and the compressor pumps the freon around the refrigerator. It's important you pay close attention to what I've just said. Now, having said that, we also want to look at some appliances that are based on the technology of conversion of mechanical energy to electrical energy. There are some devices, of course, we just have one of it, that is the generator. The generator works on the principle that mechanical energy can be changed or can be converted into electrical energy. Now, for a generator and a motor, there is no difference when it comes to their body parts between a generator and a motor, but they do different things. A motor converts electrical energy into mechanical energy, but a generator converts mechanical energy into electrical energy. You see that? Now, their input and output, they are not the same. For a generator, its input is mechanical, output is electrical. For a motor, its input is electrical, its output is mechanical. So, if you're able to turn the shaft of a motor, right, it serves as a generator. No difference. It's just their input and the output. Okay, we also have two types of generator. We have a DC generator, we have an AC generator. Okay? Now, the simplest form of this generator, the same thing I explained, although a generator works on the principle of electromagnetic induction, while a motor functions on the principle of electromagnetism. Please, you have to take note of these things I'm mentioning. So when I say the generator works on the principle of electromagnetic induction, I am simply saying that there is an experience that if you have a current, right? If you have a conductor that current is flowing through it, placed between a magnetic field, that the magnetic field changes. I'm just trying to speak the simplest language to you so that you will understand, right? There are ways of saying that maybe in higher class. Well, I just want you to follow through. If you have a conductor, the current is flowing through it, and you place this conductor, right, between two magnets, as we say in a magnetic field. If this magnetic field is changing, there's an experience that an EMF is induced in the process, in the coil. Now, this EMF that is induced in the coil can be tapped using the carbon brushes. That's the work of that carbon brush we are seeing there. It's like a terminal where you can tap this EMF generated when you rotate the shaft of this. That's exactly what I was saying. So the principle is simply saying, right, that when you have current carrying conductor, right, placed in a changing magnetic field, that an EMF is induced in the coil. EMF stands for electromotive force. Now, this induced EMF, right, also will lead to induction of electric current. This current produced in this way can be tapped from the carbon brushes, and that current is called an alternating current. That's how the current that we use in our homes, generators we use in our homes to power your AC, the generators you use, even the roadside repairers that make use of generator. This is the working principle of generator. It converts the mechanical energy into electrical energy. That's why for you to start a generator mechanically, you have to cause the armature to rotate, either by manually drawing the starting coil or maybe using electric starter to do that. Now, there's another type of generator that we use in our bicycle. We call the bicycle dynamo, right? The bicycle dynamo, like we have here, is a practical use of this generator. I don't know. If you have a bicycle, there's usually a small machine that's attached, to the tire. Once it's night and you want the headlamp to shine, just adjust the dynamo, the machine. We normally call it engine, but that's not engine, it's called dynamo. To touch the tire, as you revolve the tire, the armature or the coil is revolving, in the starter. As that is happening, an EMF is induced. This EMF induced can be used to light your headlamp, and that way you can see in the night clearly. So the faster you go, the brighter the lights. Okay, so that is how the generator works and operates. Please, I need you to really understand what I'm saying about the electromagnetic induction. I said, when you have a wire and current is flowing through the wire, We call it a current carrying conductor. Wire is a conductor. And you place it in a magnetic field. That means you have two magnets. If the magnetic field is changing, if you are rotating the magnet or rotating the coil, whichever way you rotate, right? And it's perpendicular to it. And electromotive force is induced in the coil. This law I'm explaining to you is called the Faraday's law of electromagnetic induction. So this current that is induced can be tapped, using the carbon brushes. When you tap it and connect it to your other components of your generator, the voltage regulator will regulate the voltage, then you plug in your appliances. That's how we have lights. So you can see here now that mechanical energy, which is achieved by turning the shaft, has been converted to electrical energy, and every other things will work. Okay, the dynamo, like I was telling you, also works on the same principle of conversion of mechanical energy into heat energy. Now we have other mechanical energy into electrical energy. Now we have other appliances that are also operated based on the conversion of chemical energy to heat energy. Now you know that some devices, appliances like the kerosene stove, actually converts the chemical energy we have in the kerosene into heat energy. When you light the wick, alright, of this kerosene, let's say you have of the kerosene stove, you have kerosene in the stove, in the tank of the stove, right? And the kerosene rises by capillarity to the wick or to the wood, whatever you understand it as. Now, once you light it, the chemical energy in this kerosene is converted into heat energy. This heat energy can be used to cook rice. Same thing happens too in the gas cooker. You can see the picture on the screen. You have the gas. The chemical energy you have in the gas is converted into heat energy when you light the gas. Same thing happens too to a gas lantern, kerosene lantern, and so on and so forth. Even to charcoal stove. Charcoal stove utilizes the energy, the chemical energy we have in the charcoal, and is converted into heat energy. Oftentimes you see people in the street roasting corn. It is what they are doing. The chemical energy present in the charcoal they are using to roast corn is converted into heat energy that everybody comes to say, hey, well, how much is your corn? It's that energy that is converted in that process. And a whole lot of other appliances that can do that. I've mentioned the gas cooker, I've mentioned even the gas oven too. Yes, I've mentioned the kerosene stove, I've mentioned the gas lantern, I've mentioned the kerosene lantern, I've mentioned the charcoal stove. All of these appliances convert chemical energy into heat energy. Now, having said this, I want to take you through to the ExamGuide app to see how we can use this app to practice on what we've just learned. Remember that I said that this is the app for you. If you are in JSS 1 to 3, I strongly recommend this app for you to use for your practice. The app contains all your subjects, basic technology inclusive. So the more you practice it, the more you learn, the more you become perfect, the more you do better in it. When fuel is burnt, chemical energy is converted into dash energy. Fuel in this case can be kerosene, can be gas. Anything that can burn is called fuel. Anything that can burn, that can combust, is called fuel. Alright? So if we have chemical energy that is in this field, right? If you burn it, it will convert the chemical energy into heat energy. Please take note of that. Very, very important to take note of it. The following devices make use of motor for their operation except A. Bread toaster, B. Cassava grinder, C. Electric fan, D. Fruit blender, E. Pepper grinder. Can you answer that question? Okay. Now, from option B to option E, they all involve movement of a body part of the machine. I told you that all these machines that their body parts move for them to be used or operated, they achieve that because they contain motor in them, right? So the bread toaster converts electrical energy into heat energy. So the bread toaster is the right option there. Alright, the bread toaster does not use motor to operate. Rather, it converts converts electrical energy into heat energy. Okay, that's the much we can take for now. Thank you.